Start recording. So find the domain of this function. The function is f of x equal x plus 9 over x squared minus 1. So like I said before, the domain of the function is all the possible input for this function. If I look into the numerator, x plus 9 doesn't have any issue. It's fine. I can plug any number here, any real number inside x, and the function will be good. Doesn't have issue. But if I go to the denominator down, the function here has a little bit issues. The issue is x squared minus 1 doesn't have to equal 1. So I have to look for the roots for this function. What's the root for this function? Then after I found the root for this function, I have to exclude it, remove it from the domain set. So what's the root for this function? X squared minus 1 equals 0. So I factor it. It's x minus 1 times x plus 1. This is the factor for this function, equals 0. Then I solve this function, this equation. So x minus 1 equals 0, or x plus 1 equals 0. So x equal 1 here, and here x equal minus 1. Yes, listen. Who have a question? Raise his hand. Any questions so far until now? Okay, let me continue. So this function has a domain, for all real number except these 2 points, this one and this point, except these 2 points. So these 2 points is not in the set of the domain set. So how can I explain that? I said the domain is x such that x not equal to 1 and x not equal, or I mean here, or x not equal minus 1. But the question they ask me to answer it in interval notation. So to do it in interval notation, so this is my real line, okay? This is my real line. So the 2 points in the real line is minus 1 here and 1. So the domain, everything here and everything here and everything here. So to explain that as an interval notation, it will be like from minus infinity. Yes, what's your question, Miss Miles? Can you turn on the mic and ask your question, Miles?
I can't see anything.
I can hear you.
Can you hear me now?
You turn on the mic, Miles?
Yes. Yeah. Can you hear me? Hello?
Yes.
I can't see anything on my end. Are you using the whiteboard?
Yes, Miles. What's your questions? Everyone hear me or not? Hello? Yes, okay. So So the interval is from minus. Oh, you cannot see it. Okay. So to see, try to leave the session and go back again. Leave it, like go out, log out, and log in again. Okay. So again, so as interval from minus infinity to the minus 1, such that the minus 1 is not in the interval, so it will be open. Okay. Union this one from minus 1 to 1. Again, union the interval from 1 to infinity. That's it. This is the answer. Any questions so far? Taylor, is it clear? Okay. Second question. What's the second question is 2.1 Weber sign. Question 14. Okay, go to the question 14. The last one in that section. Okay, I will do the last one of question 14 in Weber sign. Mile is here or not? Let me check. Yes, he's here. Do you see everything, Miles? Why? So everyone see the board or not? Except Miles. So try to like turn off your device if you are in the tablet or stuff like that. Like everything, turn off and turn on again. Okay. So now question 14, Weber sign. 114. The question is evaluate the function at the indicate value. So f of x equal the absolute value for x over x. Evaluate f of 1 over x equal. So we have to plug this one inside the function here. So what I get, the absolute value for 1 over x divided by x. Okay. So this is equal the absolute value for 1 over x times uh, times 1 over x, because here we have divide become multiplication and we do the reciprocal. So we can here simplify it. The absolute value for 1 is 1. The absolute value for x is the absolute value for x. So here we can simplify it to the absolute value for 1 over the absolute value for x, and this is equal 1 over absolute value for x. Okay. Oh, here, sorry. Here we have to plug again 1 over x. Here 1 over x. Because we plug this value, we plug this value inside this function. So here will be 1 over x, the absolute value, and here 1 over x. Okay? So will be only x here. And here will be like times x. So the answer is x over 1 over the absolute value for x. It makes sense? Taylor? We plug this value inside this function. So here will be like the absolute value for 1 over x over 1 over x. And this is equal the absolute value for 1 over x times here, because of division. Division means we do it multiplication and we do the reciprocal for 1 over x is x. So this is equal, and I know the value for the absolute value for 1 over x is the absolute value for 1 divided by the absolute value for x, and this is equal 1 over x because the absolute value for 1 is always 1 over the absolute value for x. So again, the value for this one is here, and the value for this one is this here. So it'll be like 1 over the absolute value for x times x, and the final answer is x over the absolute value for x. Any question? Anyone has a question here? Is it clear for all? If it's not clear, please ask. I can answer it. Vivian, is it clear? Miles, is it clear? Do you see right now, Miles? Matthew, Kate, is it clear? Okay, good. Now a question for Damien. Question 4, part 4. H of minus x, 2.1. Okay, go to 2.1. 2.1. Question 4. H of minus x. Okay. Okay, good, Miles. Yeah, what's your question, Jonathan? Okay, let's go do this one for Miles. Is it question 4? Evaluate the function at the indicate value. H of x is x squared plus 9 over 10. And the question is evaluate h of minus x. So again, I have to plug this value inside this function here. So what I get, h of minus x equal minus x squared plus 9 over 10. This equal, the minus x squared will be like x squared, because the square distributed to the minus and distributed to the value x. So minus 1 squared is 1, and x squared plus 9 over 10. This is the answer. Okay, Damon. Okay. So what's your question, Jonathan?
Can you hear me? Hello? Can you hear me?
Jonathan, what's your question?
Oh, can you hear me?
I can't hear you.
Okay, so is the
Again,
question
speak in the
from
mic.
okay. Is the question from the
You're
homework
saying.
is number 17? Do you want me to say the question?
Can you try again, Jonathan, by the mic?
Okay, so the question is finding the domain of the function.
No sound. I can't hear you. Okay, write it down. We'll check. We'll figure out what's happened. Can you write it down? What's your question? Okay, no problem. So let's go to the new section. It's 2 point section 2.2 graph of functions. The graphs of function. So first things I have to do to know the definition of the graphs of function by plotting a point. First things, graph of function by something is called plotting point. Plotting point. What does that mean? This is mean the graph of f, the graph of the function f is the set of all points is the set of all points. Its set has points x and y such that y equal f of x. This y is equal f of x. This is the definition. This is the first part of this section, graphing of function by plotting a point. So we will graph the function by a point by point. What does that mean? It's mean a set, here is a set, has a point x and y such that y is the value of f of x. There is okay, and there is different types of functions. first one is called a linear function. Linear. Like we said before, there's a linear equation. We have a linear function. Linear function, it's look like exactly f of x equal to mx plus b. M is the slope here. This is the slope. This is value variable, and here is a constant number, any real number. It's we the intercept. Okay. The second type of function is the constant function. Constant function. What does that mean? Like the function f of x equal constant number, like c. C, it's real number, belong to the R. Okay? So we have linear function f of x equal mx plus b. M is the slope and b real number. And constant function, it's f of x equals c. C is a real number. Okay? The third type of function, so I will erase this one, okay? Third type is called power function. Who asked? Anyone has a question? Anyone has a question? Okay. So the power function. What does that mean? The function look like f of x equal x to the n. X to the n. Like for example x square, x cube, like a cube function I mean. X to the power 4 or x to the power 6 or whatever. Any n. N here is integer number. Or we have another kind, is the fourth one, number 4 is the root function. Root function. It's look like f of x equal x to the 1 over n. It's root function. Okay, this is just types of functions: root function, power function, constant function, linear function. Okay, so let's go to do example. Can graph the function by plotting a point. Example. Let me see if I think. Now example 1. So sketch graph of the following function. The function is f of x equal x squared. How can I sketch graph for this function? So I have to get values x and values for y. It's f of x. That's equal x squared. And I have to pick up any points I want. Like for example, -2, -1, 0, 1, 2. So I give you like around 2 minutes or 1 minute to do it by yourself, and then I will graph this one. Okay? So all of you did this question? This example, I mean, sorry. Okay. I need all of the student do this example. It's clear, direct. Okay. So -2 when I plug this value. Okay. So when I plug the -2 inside this function, they give me 4. Good. The -1 when I plug inside the function, they give me 1. The 0 they give me 0. The 1 they give me 1. The 2 give me 2. 4. Sorry. So how I get this value? Because -2 here, -2 squared, they give me 4. That's why I get this 4. Again, the 1 squared, they give me 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. The 4, this is the value. Now I graph this function. Here, 1, 2, 3, 4, -1, -2, -3, -4. 1, 2, 3, 4, -1, -2, -3, -4. Now graph. At 0 is 0. This is the first point. This is the first point. At 0 is 0. At 1 is 1. Here is 1. This is the 1. At 2 is 4. This is 2. Here is 4. At -1 is 1. And at -2 is 4. Is 4. So the graph will be like that. It's like that. And it's continuous. You continue. Okay, second example. Any question for this one so far? For who did not do that, is it clear for? Let's go to the next one. Example 2. Graph the function h of x equal the square root of x. How can I graph this one? Again, by using the plotting point, I choose any random point x, and h of x equal the square root of x. Okay? So, choose any point. I can choose the negative points here, like -2, -3, -4. No, I can't. Why? Because the domain for this function is all the positive number and 0. So I can't plug inside this function negative numbers. I can't plug -4, for example, or -1, for example. I can't. Or like any negative number, I can't plug it inside this function. Why? Because it will be undefined. So I will start from the 0 here. The 0 is work. Here I can't plug any numbers. Undefined. Undefined for real numbers. For real numbers. So I start from the 0 and 1 and 4. So at 0 is the square root of 0. You give me 0. At 1, the square root of 1. You give me 1. At 4, square root of 4. It's giving me 2. Then I graph this function. So now to graph this function again, here 1, 2, 3, 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, but I will not use it. So at 0 is 0. At 1 is 1. At 4, 1, 2, 3, 4 is 2 here, and so on. So the function will be like that. Any questions so far? No. Okay. So what's the domain for this function? Domain, it's the possible input. Domain. What's the domain? It's x such that x is greater or equal 0. This is the domain. Okay. Next example. Now, g of x, example 3. G of x equal cube, x cube. How can I graph this function? Again, using any random points, x and g of x. Please, anyone he doesn't understand, please message me or tell me I can't understand this question or I can't understand what are you doing. I will explain it again and again. Don't let me go to another things and you can't understand that. Okay. So x and g of x. Let's choose any. Here the domain is R. The domain for this function is R. Here the domain is the real number or real number. I can plug any number, negatives, 0, positives, rational numbers, irrational numbers. Everything is fine. So I can choose any numbers here, like for example -2, -1, 0, 1, 2. Plug the -2 inside the x cube. -2 cube give me -8. Okay, -1 cube they give me 1, -1. And the 0 is 0, the 1 is 1, and the 2 is 8. So again we graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Same things here. At 0 is 0, at is 1, at 2 is 8. It will be like here. Again here. At -1 is -1. At -8, at -2 is -8. Be like here. So the graph of this function will be like look like this. Any questions so far? Good. Good. Uh, Kate, can you please try to speak in the mic to check if I can hear you or not?
Me? Kate? Hello?
I can't. Why? I don't know why. Ah, so no one can hear you too. Ah, so all the class cannot hear you.
No, they said I can hear her.
But do you hear me?
I can hear you, yeah.
Mm.
Can you hear me?
Okay, I will check next time. I don't know why. What's happening?
Okay.
Okay, let's go to another example, or to second part of this function. So now we will learn how to graph a function is piecewise function. So now graph piecewise function. Graph. So let me give you an example. A piecewise function, it's look like that. F of x equal, like the function has two parts. First part is x squared. Second one is 2x plus 1. Here, when x is greater than, less than, or equal 1, when x is greater than 1. To graph this function, we starting graphing the first one, then we go to the second one. So for the first one, we start from the domain. The domain here, they told me, start from the x is less than 1. Okay? Then we graph this function starting from the domain when x is greater than 1. So let's start from the first function, x squared. Okay. Again, we're using the plotting point for the function f of x. So f of x here, the plotting points, x and f of x equal x squared. And I start from domain from when x is less than or equal 1. I start from the 1 because it's in the domain. And 0, minus 1, minus 2, all these numbers. Okay? So at 1, the function give me 1. At 0, they give me 0. At minus 1, they give me 1. At minus 2, they give me 4. Just block this value inside the function. And for the second function, x, and f of x equal to x plus 1. So we start from the domain. The domain is x greater than 1, okay? So which point I have to start here? Which point I have to start here? 2, exactly. 2 is not 1. If I want to start from 1 is okay, but we will not, it will be like open circle. It will not be in the domain. So let's start from the 1, and I will show you in the graph. It will not be inside like, it will not be inside the graph. Okay, let me start from the 1 because I don't want to forget, because one half it's inside the domain, and 1.1 and 1.2 1.3, this all little value inside the domain. So I have to start from the 1, but the 1 will not be inside the graph, so it will be like open circle. I'll show you how. So I start from the 1. F of 1 is 2 times 1 plus 1 is 3. Now I start from 2. 2 times 2 is 4 plus 1, 5. 3. 2 times 3 is 6 plus 1, 7. 4. 2 times 4. 2 times 4 is 8 plus 1 is 9. So 9. Now I have to graph this function. So I start from the function f of x equal x squared. At 0 is 0. At 1 is 1. At minus 1 is 1, 2. At minus 2 is 4. Okay. So the graph for f of x equal x squared will be here. And this is inside here. Now let's go to the graph, the second function, f of x equal 2x plus 1. So at 1, we start from the 1, it will be like 3, and it will be open circle. This is important. Is not inside the domain of the function. At 2 is 5, at 3 is 7, at 4 is 9. It will be like, look like linear function. This is linear function. Linear function will be like that. Okay? So at 1 will be like 3. Here is the 3, but it's open circle. This is important. At 2, it will be like 5. This is 2. Be here 5. This is 5 here. At 3, be like 7. This is 7 here. At 4, to be like 9. This is 9. Okay. Any questions so far? No. No. Question, please ask. If it's not clear, please ask. Okay. Let's go to second example for piecewise function. What about the rest of the student? Sharon, Taylor, Ronald, Oscar. Is it clear? Is it fine? Angelina? Yes, we have to include it. You know why? Because it's first of things, 3 is not, number 1 is not in the domain, not 3. 3 is in the domain. 1 is not in the domain because x not is greater than 1. But the value 1.1, it's inside the domain. 1.2 is inside the domain. 1 point, like small numbers, 1.00001, for example. It's inside the domain. So that's why we have to plug this value at 1, and we have to keep it open because the 1 at 1 exactly is not in the domain, but 1.1, it's close to the 1, it's inside the domain. That's why we have to plug the 1, but we have to keep it open circle. It makes sense, Taylor? Yeah, I know. But when I plug the 1, it's 3, but I have to keep at 3 open circle. Open, not include. Not dark, is open. That's mean it's not in the domain, but all the value greater than 1, it's inside the domain. Like 1.1, 1.2, 2, 3, 4, 5, all the numbers greater than 1, it's inside the domain. But at 1 exactly is not in the domain. That's why we put it, when we graph it, we keep it open circle. Now let's go to the second example. Example 2 for this section, for this part. The example is graph the function f of x equal the absolute value for x. So the nice things for this function, we can recall this function in as a piecewise function. So this function would be like exactly like x or minus x here when x is greater than 0, when x is less than 0, here greater or equal 0. So the nice things for this function is always greater, the value for the absolute value is always greater than or equal 0. Always give me positive values or 0. If I plug the 0, they give me 0. If I plug the positive, they give me positive. If I plug the negative, they give me positive too. Okay. So how we can graph this function? Again, we have piecewise function. So we have this function and we have this function, two functions. So let's start for the first function, x and f of x equal x. So we choose any random points. No, we have to start from the 0 here because the domain they give me, I have to start from x is greater than or equal 0. So starting from the 0, the 1, the 2, 3, and all the numbers. At 0 is 0, at 1 is 1, at 2 is 2, at 3 is 3. Now for the second function, f of x equal, for the second function, x and f of x equal minus x. Again, I have to start from the 0, but it will be open at that point. Minus 1, because minus 1 is less than 0. Minus 2, minus 3, minus 4. At 0 is 0. At minus 1 is 1. Because why? Because minus times minus 1. When I plug the minus 1, they give me 1. Minus 2 is 2. 3, 4. Now, how can I graph this function? Again, so for the first function, f of x equal x, when x is greater than or equal 0. At 0 is 0. At 1 is 1. At 2 is 2. At 3 is 3. And this function is linear, so it will be like line. It's close to the line. It's linear function. For the second function, f of x is equal minus x. At 0 is 0, but it's open. But it's already inside the domain because it's already, we used it before from different function. So it'll be close. We stay open, but the other point is closed. Okay, the other point is closed this point. Again, at 1 minus 1 be 1, minus 2 is 2, at 3 is 3, minus at minus 3 is 3, minus 4 is 4, and again it's a linear function. This function look like this. Any question? Good. Why? Because we use okay. It will stay open circle, but because we used it before and it was closed before, so we'll keep it closed. Because we used it before in different function, because this function of x is like one function, but this function has two parts. X when x is greater than 0, or the second one is minus x when x is less than 0. So, because we used this point before and it was closed, we keep it closed. Always, when you see something like that, if it's closed before, or if we close it, the point by different function, it will stay closed. I hope it makes sense for you. Okay. Another question. Is it clear for all? Yes. Okay. So now let's go to something part 3 of this section. It's called the vertical line test. By this line test, I can test the function, the graph. Is it a function or is not a function? Okay. The vertical vertical line test. Which graph represent function? Which graph function? So the vertical line test, it's like line. We draw a line for all points in the domain. If this vertical line it crosses the function or the graph of the function in 2 points, that means this graph is not satisfied to be a function, is not represent a function. But if this line cross the graph in just 1 point, that means this graph is a function. Okay, example. For example, if I have graph something like that, this graph has a name f of x. Is represent a function? So I have to go to check by using these things, the vertical line test. So I draw lines, line, 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 and I check. This line, the first one, number 1, cross the function just in 1 point. Second one, cross the function in 1 point. Cross the function in 1 point. Here, cross the function in 1 point. So all of them cross the function in 1 point. That means f of x is represent a function. So this is function. This is function. But if I have something like that, like this, like for example, uh, like this. This is f of x, g of x. Okay, and now I have to check. I want to test. So I draw a line for most of the domain of this function. So I see this line, this one, number 1, cross the function, this is the x line, x-axis, and this is the y-axis. Okay, so the first one here, it cross the line, this line, the vertical line, cross the function in 2 points. This is the first point, and here the second point. And the second line, the same things, cross the function, the graph in 2 points. This is the first point, this is the second point. And this is the line, the last line, look, cross the graph in many points, look, for all points. So that's mean the graph not represent a function. So the graph g of x does not represent function. Any questions so far? Is it clear for all? How can I check the graph represent a function or not? By vertical line. Okay, Taylor. What about student, the rest of student. Okay. John, how is it? Is it clear, John? Jose, okay. So by the vertical line, I can know this graph is function or not. Another examples to check this graph represents a function or not. So the example is, I give you like 2 minutes to solve these questions, this example. The example is, check which of the graphs represent a function or not. So the first one, circle, this is A, B, something like that. C, something like that. D, something like this. So I give you like 2 minutes to think about it and give me the answers. Okay, who will answer A, B, C, D? Jonathan, A and D not function and B and C is a function. Why A is not a function? Why A does not represent a graph function? Because if I want to use the vertical line test for this circle, look, the line multiple times, touch multiple times, or intersect the graph in 2 points or more. So if we intersect the graph in 2 points or more, that's mean the graph does not represent a function. Now B, look B, everything is fine. Intersect the graph in 1 point only, look, everything is fine. So intersect the graph in 1 point, 1 point, 1 point, 1 point. So for A, does not represent. For B, yes. Now for C, same things. If I graph like lines, everything is good, line. Hold on, but I draw this one wrong. It's supposed to be like that. It's not like this. My graph is look like this. So now it's represent a function. That's true. Look, every vertical line intersect the graph in just 1 point. So this is right. Here is function. Yes. For D, is not a function. It's not represent a function. Why? Because if we look into the graph, it's intersect in 2 points, and this is mean does not represent a function. Does not represent a function. So the only graphs represent a function is B and C. Any questions so far? Okay, let's go. Good. So now I can know this graph represents a function or does not by the vertical line test. But what about if I don't have a graph? I have just like function. How can I check, or I have just equation? How can I check this is equation represent a function? How can I know this equation represent a function or not? Okay, let's go to the next section, the last section of this, last part of this section. It's like which equation represent a function? Which equation represent a function? So let's start, for example, by example can explain which equation represent a function. For example, if I have example 1, if I have y minus x square equal 2. Okay, so first things, when you see a question like that, is the equation represent a function or not? So to check that, first things I have to write y in the standard form. So I have to rewrite this one as y equal something, equal, like moving everything to the second side. So it'll be like 2 plus x squared, or I can say y equal x squared plus 2. Okay, so now this is as equation form. This is equation form. Now I have to change it to the function form. So f of x equal x squared plus 2. This is equation form. This is function form. But as we look into this function, every single value, every single input, they give me just like every single input, they give me one value. Or they give me like many, like here, if I want to do the test line, vertical test line, the line intersect for this function in just 2 points. So for every value I plug it inside this function, they give me one value. So this equation represents a function, and I know how to graph this one by using the plotting points, and it will be look like this. After using the plotting point, look like this. Because every value plug it inside this function, they give me one value. That's mean this equation here this equation represent a function. Let me give you another example to show you which equation does not represent a function. Example for that. If I have equation look like this, x squared plus y squared, it's the circle with the center 0 and radius is 2. So first things I have to rewrite this equation as y equal something. So y squared equal 4 minus x squared. Take the square root for both sides. Square root of y squared equals square root of 4 minus x squared. But because here, as I said before, the absolute value, this is equal the absolute value for y. This is equal the absolute value for y. Equal square root of 4 minus x squared. And I know the absolute value for y has two values. We look like y equal plus negative square root of 4 minus x squared. Or you can skip from this step to this step without doing that. Okay. So because every single value I plug it inside this section, every single value I plug it inside this equation, they give me two value. Why they give me two value? Because we have plus negative. That's mean every value I plug it inside this equation or inside this x, they give me two values. One is positive, one is negative. When the equation give me two value, that's mean this equation not represent a function. This equation is not represent a function. Why? Because the positive, negative. Because this things, the positive and negatives. That means every value I plug inside this equation, they give me two values, and this is not a function. Suppose they give me one value to be a function. Okay, so before in chapter 1, I said you can skip this value, you can skip it, you can not write it if you feeling confused. But in the first chapter, first of all, is it clear for all these things before I erase it? Okay, so I will erase the things. In chapter 1, I said always the absolute value for x to the n, and here we have n. If n is even number, the even number is 2, 4, 6, 8, 0, whatever. This is even numbers. The 0, I don't know exactly. It's not -2, -4. We will not use the 0 here. Not because here we will not use the 0. Not because it's even or odd. We will not use the 0. If it's n is even number, like for example, square root of x squared, this is always the absolute value for x. So here the value always the absolute value for x. Always. Another example, square root, fourth root for x to the 4. This is the absolute value for x. Another example, the sixth root of x to the sixth is the absolute value for x. But if n is odd, the answer is the nth root x to the n is equal x, whatever x is negative number or is positive number, always x. For example, the cube root, third root for x minus x, for example, like that, to the 3 is equal minus x. Another example, 3 to the x 3 is equal x. Okay, does it make sense? Okay, who asked the question? Kate. Yeah. Liana, does it make sense for you? Okay. How is now? Is it working properly, Nicole? But I recording this video, so if you did not like joining this section, you can like watch again. You can watch again. I recording this session. Okay. Questions so far. Okay, let's go back again. So now if I give you any equation, you have to check. If I give you equation, you have to check. You have to make the equation in the standard form, y equals something, and you have to check it give me two value or one value. The equation represent a function. If they give me two value, that means the equation does not represent a function. Let me looking for example for these things. Another example. I give you like 2 minutes or sorry. Example. Check this equation represent a function or not. 2xy minus 5y squared equal 4. Another one, this one. Second one is x equal y squared. I give you 2 minutes. Oh, I have to leave at 11 o'clock. So we have 10 minutes left because we start earlier today at 9:30. So who will do the first one? Good. Who will do the first one? Okay, who will do the second one? It's easy. 1? Hello? Everyone hear me or not? So who will do the second one? Okay. Second one is not a function. That's true. Second one is not a function. Yes, let me explain why. Yeah, that's right, Miles. Second one is not a function. Why? Because I will start from the second one. Here, the second one. If I wanna write this function in the standard form, y squared equal x. So that's mean y take the square root for both sides. So it'll be like positive, negative square root of x. And because we have positive negatives, that means every value I plug it inside this equation, they give me two value. The first value is positive value, and the same value they give me like negative value. Like for example, if I want to plug, for example, the 4 x equal 4, it will give me like positive and negative 2. If I plug 16, for example, x equal 16. So when I plug this one value inside this equation, they give me a positive, negative, the square root of 16, and this is mean positive, negative 4. And because they give me two value, positive and negative, that mean is not represent a function. So number 2 is not a function. Now for number 1, who will do the first one? Hello, now you hear me, right? Sorry, I don't know what's happened. Disconnected. Okay. sorry. Okay, who will do the first one now? Okay, so who will do the first one now? So the second one is not a function. Why? Because we have two values, x positive and negative. Positive and negative. So first, for first one, let's do it. For the first one here, I will erase everything. So I'll erase everything and go to the first one. It's 2x minus 4y squared equal 3. So first things I have to rewrite this one in the standard form. This is my question? No, it's 2x, I think. 2xy, right? I think 2xy minus 4y squared minus 5y squared equal 4. I think this is the one, right? This is the one? Yes, okay. So first things we have to rewrite this one in the standard form, y equals something. So here it's a little bit harder, but we can do it. So it will look like okay. So it'll be like taking y, factor this one. We factor this one. This one, it will be like 2x minus 5y equal 4. But still we have so still because we have y squared, so y equal 4 over 2x minus 5y. This equation does not look like as a function. Does not look like as a function. Why? Because 2x minus 5y squared equal 4 because the y here and the y here in the same time. So if I want to plug x, they will not give me like direct value for the y. Or if I want to like factor it more, let me check if I can factor it more. Give me like y squared so we'll do this one next time. But this one, if I want to factor it, you can think about this one and you can give me the answer. If I want to factor this one to be like y times 2x minus 5y equal 4 and for y equal 2x minus 5y. Equation does not look like 2x squared. I think the problem was 2x squared minus 5y squared. 2x squared minus 5y squared. Yeah, it will be easier, but this one, okay, if we want to do this one, we remove the y. Okay, if we remove the y here, without the y. So it will be like 2x, this is the problem, right, Jose? 2x minus 5y square equal 4. So now we can make the y in the standard form minus 5y square equal 4 minus 2x divided by minus 5 for both sides. So y square equal 4 minus 2x divided by minus 5. Take the square root for both sides. Y equal positive negative square root of 4 minus 2x over minus 5. So because we have two values, x positive and negative, that means is not, this equation does not represent a function. Is it clear for everyone? I have to leave right now. And I see you next Tuesday at 10 10 o'clock. You're welcome, everyone. I don't know exactly about the games right now. I did not get any email from the department, everything, but I will check. Yeah, it's recorded. So you can find it recorded by going to the Blackboard, to the press to the Math190, to the sessions, the Blackboard Collaboration Ultra. There is 3 bars in the left, in the top left. Press there. They give you the recording videos. How many questions are uploading in the website yet? I don't know exactly how many questions, but I upload most of the time the sections, not the questions. So you have to go to the section and check how many questions there. Okay, Tashi? Just we do like 2 sessions until now. Just 2 sessions. Tashi, we did only 2 sessions. This one and last one. Okay, so I have to stop recording this video right now.